Hi everyone. Today we're going to talk about averages, some easy basics about average. Usually there are three types of average here: mode, median, and mean. So we're going to talk briefly about these things here. So we're going to talk about mode. Mode, you might all of you know what's mode. It's the most repeated number here. So look to this definition here, telling you what is meaning of the mode, which most often number or repeated number, more frequency number. So if you look to this example here, what is the most repeated number? You get two is repeated once, three is once, four twice, five once, eight. So the number who's repeated much more is called mode. So you will find the answer here. What is the mode of this sequence? It's four. And what about median here? Median, from its name, is the middle number. So when you have sequence or any number on numbers on any pattern like this one, in order to get the median here and remember this, you need to arrange it. So we can't select the median in this way. We have to arrange it either in ascending order or descending order. So once you have arranged your numbers here, you select the middle number. So here the middle one is 5, as there is three before three numbers before it and three numbers after it. So the middle number is 5 here. Even if you arrange it in descending order, you will get the same answer here. The middle number would be 5. And the third type of average here, which is called mean, and the most of students and people understand what is the mean here. The mean, which usually we mention as the average here. And even if you use Microsoft Excel, they don't say mean, it say the average here. And how to calculate the mean? Adding all values of set data together and divide them by how many data you have. So summation of all values in your data here divided by how many data you have. And this could be written as x bar. So x bar is the mean. So remember this means could be abbreviated as x bar equal summation of all data. So this symbol here means summation of all data. X means the data divided by how many data you have. So this is n. So this is the mathematical equation for to calculate the mean. And if we have data like this one, and we need to calculate the mean, we add all of this together, 10, as you can see, plus 2, plus 30. So all data we added together here, as you can see, added all together, divided by how many data. How many data we have? We have 10 numbers, as you can see. So we add all data, summation of x, divided by how many. This will give you the final answer, which is the mean. So this is the meaning of the mean, and this usually we use this in our daily life, the mean of things. For example, when we calculate the score of classroom, so we say the mean of the grade or marks of this class, for example, 80%, 70%. This school has success of A star or A or B or B or C, like 50%, 60%. So usually we use the mean to reflect the average of scores, of heights, of whatever we are looking at. And the point here, this will bring us to the range. For example, when I mention that the average or the mean of the grade of this class is 80%. When you hear the 80% of success, for example, or the 80% the mean of success of the students, or we can say in another way, how many students got score, what is the average of the scores of this classroom. So if we say the average of the score is 80%, this will come to your head or come to your mind that most of the students got around 80%. Might be all the class got 80%, but we don't know how many students got 80%. Might be all students got around 80%, 81, 82, 78, 75, might be, and might be not this scenario, might be many students got 100% and some students got 0%, and when they add it together and divide by how many data we have, it became 80%. So we don't know how data is scattered actually. So in order to understand how data is scattered among the students, we need to calculate the range here, and the range is a quite powerful tool to understand the fluctuating of results. So the range of the data, how to calculate it, is the difference between the largest and the smallest value, as you can see here. So if we look to this example here, and I ask you to the range here, it's the difference between the largest, so this one is the largest, and what is the smallest value, 3. So 12 take away 3 would be 9. So these are the range here. Another way to calculate the scattered data or the spread data about the average, we use a standard deviation. A standard deviation use such equation here. I'm going to explain how to calculate the standard deviation. But from this data before, look to the example here. X reflects the data. Take away X bar, as you remember, it's the mean summation of this data, and divided by n, take away 1 under square root, get you standard deviation. So look to the data that we have here. We have this sample of data. So if we add these together, 4, as you can see, plus 1, plus 3, plus 3, plus 1, plus 0, plus 2, divided by how many data we have, 7 data here. So this will give you mean here. So we usually, if we do this manually, we're going to write the data here. This is just explain manual, but it's much easier when you do it in Microsoft Excel or Google Sheets. Just for manual thing, for your information, we write all data that we have. So this is the data that we have in the example for 133,102. And then we calculated the mean, which is 2. So we write 2 here. This is the mean. And then we need to apply this equation here. X take away X bar, this one. So X bar is the mean. So I calculated X is the data. You have take away the mean. So 4 take away 2 is 2. 1 take away 2 is minus 1, and so on. You write this column here. And then we need to square, because the equation itself say X take away X bar is squared, as you can see here. So we do this one here. We have X take away X bar. For example, here 2 squared become 4, minus 1 squared become 1, 1 become 1, and so for example, minus 2 become 4. And if you look to the equation again, it's a summation of this number, summation. So we have to, after we calculated this one, we add all of them together to get the summation. So we add all these things together here, and we get value 12. Hope this is clear. And when we got 12 here, we use it in the equation, as you can see. So this part will be 12 divided by how many data, 7, and then under square root, it will equal 1.3, and this is the standard deviation. Then we look to percentage with plus 1 standard deviation. Usually, this is the other way to calculate the range. Calculate the range. If we have the mean here, we take away the standard deviation in order to get the lower limit, and add it to the standard deviation to get the upper limit. And how to do this one? We count how many data values lie inside this range. This is the thing here. So if you have upper limit, mean plus the standard deviation, and mean take away standard deviation, we count how many data we have lie between the upper and lower limit, and then we calculate percentage afterward. And how to do this one? For example, if I have lower limit of lower limit, this is the lower limit here, lower limit. For samples, I have say if we look to bricks, and we look to the compressive strengths of this strengths compressive strengths. So I say the lower limit for bricks should be 36 megapascal, and the upper limit should be, for example, 60 megapascal. So this is the upper limit. So this usually around the mean here. This is the mean. So we need to calculate how many bricks, for example, lies between these values. Any values above this 60 or less than 36 will not count it. For example, if I have 100, or say not 100, say 50 brick 50 bricks here total, but when we count the bricks which shows data between this lower limit and this upper limit, we found they are 25. 25 bricks. So 25 bricks out of 50 are lies between this lower limit and this upper limit. So when to calculate the percentage for the samples in this example, bricks lie within this range between the lower limit and the upper limit, we say 25, this is lies between the upper limit and lower limit, divided by the total, which is 50, and then times 100. So 25 divided by 50, 0.5 times 100, it would be 50%. So this is to calculate the percentage within one standard deviation, plus minus standard deviation. Hope this is clear. And then we will continue with other video. Thank you.